So what we're going to do is we're going to, if I go back to my C++ classes, we're going to start off by, I think what we'll probably do is go through the tiny shooter pawn. Let's just see if I can switch that. Yeah. Still searching for something. Oh, hooray. What I'll probably do is talk you through the tiny shooter pawn class first, just so you understand what's going on here. So when you create the project, by default, some of these classes won't exist in here because I've created those myself, but essentially you'll have tiny shooter pawn, you'll have a game mode class, you'll have the actual game kind of module, what's called class. You'll have projectile. You won't have any other classes. So we're going to add some of these things obviously as we're going along, but we don't need those open for now. Don't need projectile or any of that stuff. Get rid of you. You can go away. Nice. The tiny shooter pawn is the class for that little spaceshipy thing. Yeah, the little blue guy. So it allows us to move. The movement's really bad. It allows us to shoot. You notice the projectiles are kind of coming up out of the screen when they hit each other. That's bad, we'll have to fix that. So, going back to the code, let's talk through it. So, coming from the top, there's a couple of, this core minimal thing allows you to use some base classes in Unreal Engine. They've actually changed some of the way this code architecture is working now. I'll talk about the generated classes in a second. Well, maybe we'll cover that now. So, when you declare a class in Unreal Engine, you're usually going to define a class based on one of the existing classes. And one of the best ways I've found for understanding what the class does is if you right click it, it's not working on here, that's weird. Usually when you right click it, there we go, and go to definition, it'll actually open up the source code for the header file of that class. And usually you can tell if you read through the source code what all of these things are. We're looking usually for the virtual functions for these things. So anyway, top to bottom, a couple of included header files. You should already know what header files are. The generated.h is actually, if we, let's see if we can open it, is actually generated by a process that is done by the compiler. Don't change it. Essentially, these classes are constructed by a thing called the Unreal build tool when it comes through the code trying to figure out what to incorporate into the final executable. It's one of the weird things about Unreal Engine that they actually do this pass. But it means that they can do things like use properties which aren't in the C++ language. So it's kind of a necessary feature. It's not great. If the language was better, if C++ was better, this wouldn't be a requirement really, but it kind of is. So what they do is they have a separate executable that before they compile everything, another executable called the Unreal, well, they've got a Unreal header tool, Unreal build tool. Unreal build tool tells the Unreal header tool generate a new generated.h file based on the contents of the class definitions here. So essentially they've got a little compiler that comes through here, checking the header, looking for all these U property values and things like that, and all of this U class and generate body stuff, and it generates some code that it sticks in this generated.h file, which means that if it wants to declare that one of its properties is available to edit somewhere, that generated.h will build all of the boilerplate in for making the engine do that. So it's kind of a bit of a, I'm not sure I like it, but it is what it is. So from top to bottom of this class, uClass is one of these header tool kind of declarations, so you'll get used to using these after a while, but for now we'll try and derive from existing classes and use the inbuilt tools for creating them. Blueprintable means it can be made into a blueprint, which is something we'll do quite a lot of as well. It's saying this class is derived from a class called apawn, and apawn is one of the classes that allows you to have control of it. So it's a thing derived from a actor, so we can go to the declaration of that. Definition, sorry. And you'll see it's derived from a actor and a navigation interface. So that means that, if we just go back, I just did Control and Tab then to get back to it. A tiny shooter pawn is basically a type of pawn class. So we can make a whole bunch of functions derived from virtual overrides for that kind of stuff from this pawn class and get all the functionality of that. But this class, this a pawn, is derived from a actor, so we can use a actor's functions as well. And that's where most of the sort of functionality will come from. So the class is derived from this one. It's got a generated body, which means that it's going to create some boilerplate code, and this generated.h file is going to know about it. And then it declares a bunch of uProperties. Now, uProperty is a macro that gets gets read by the Unreal header tool and shoved into this generated.h, which means that these properties here, basically they're just variables that have been declared as uProperties, which allow them to be accessed by the Unreal Engine editor and other sort of tools and stuff. So there's three classes. One's a static mesh component, which means it's got a 3D model. One's a camera component, which means it's got a camera. One's a spring arm component, which means it's kind of a thing that positions the camera relative to the model. Now, this a tiny shooter pawn is just a default pawn class that's created from that template. So it would be whatever the name of the game you created, a something name pawn kind of thing. There's no specific reason why it's called tiny shooter pawn. It could be a my other game pawn or whatever. It's got a bunch of little things for things like where's the gun offset, where it's going to fire from, how often it fires, how fast it moves, what sound it's going to play when it fires. Now, the thing that you'll probably notice quite a lot with these classes, these ones derived from actor, is that you'll often find Epic doing this, where they kind of tell you these virtual functions, these function overrides, that's kind of a weird name. These function overrides are ones that are coming from actor. So they're telling you this is coming from the actor class. And this is probably not a bad way of sort of making sure that everybody understands which function, which base class this thing comes from. But what this means is that a actor is the thing that defines where tick is, and we're overriding that in our derived class. Same for setup player input component. Fire shot's a specific one to this function, this class, so we're not going to make it virtual because it's not in a base. Same for shot timer expired. Static names for what they call bindings, and we'll have a look at those in a second. Static const just means it's a constant static value, so it's just a name that they give it, and they'll declare the name somewhere else. uint32 is a type, integer, 32-bit integer. B can fire. I don't know why they didn't declare that as a bool. It's kind of weird, but I mean a bool is basically a uint32, so whichever way you want to do it. Here's a new one, ftimer handle. Ftimer handle is essentially an Unreal Engine type, which works with the Unreal Engine timer system, and we'll see that in the actual code in a second. And then force inline is a macro that just basically forces an inline version of some of this code, and they're doing get ship mesh component to essentially give three getter functions that return the three components they've created variables for here. So these are all pointers to components, and these are the getters for those components in case something needs to get it. So let's look at the actual header for the CPP file, and obviously the header for the class that they've just created first. Projectile class declaration, so it can fire projectiles. Timer manager, so it can use timers. Constructor helper is for things like create default sub-objects and stuff like that. Camera components, static mesh components. What I'd suggest you do is don't necessarily try and understand all of this straight away. Just use the class creator, which I'll show you in a second. Well, I'll show you in another video, but I'll show you fairly soon. Worst comes to worst, cut and paste all of this into one of your actors if you need to, and then just change the name of this thing to whatever class you've created. So let's look at here. If you remember in the header file, there was that static constef name. Well, here's where we actually give them a value. So constef name, potentially a pawn. So it's basically saying that in the pawn namespace, this thing's called move forward. It's just setting a static value for those static variables. And then we come to the class declaration, and so if you remember up here, we've got the class declaration. So here we can actually create some stuff. And what it's doing is here, the first one, this is the fObject finder, which is looking for a static mesh in the actual game directory. So this is essentially saying use a particular mesh file for our ship. So if we wanted to do a different ship, that might be a problem if we wanted to override what this mesh was. It's kind of hard-coded in here, which is not the greatest idea. So create default sub-object. The uStatic mesh component is a thing that renders a uStatic mesh. So the uStatic mesh component requires the name of a mesh essentially to use, and because it's created the uStatic mesh thing here, it can pass that in there. So essentially what we're saying here is find me the object of type uStatic mesh, call it ship mesh, and then give it the relative path of that object that we're going to use for the mesh. And then here we're saying create the default of a uStatic mesh component and use that directory entry that we gave it, and return the ship mesh component, which is, if we go back up to here, this one here. So it's declared as a static mesh component pointer, and we're just going to fill in the component pointer. Next part is we're going to set that static mesh component into what's called the root component. The root component is essentially like the thing that tells this tells the base class, the actor class, where the thing is in space. So what he's saying essentially is we've created this pawn class, which is a controllable actor, and the thing that's going to define where it is in space is going to be the mesh, so the 3D model of it. You can make a bunch of other types of components, the root component, so we might have like a spaceship that's made of a bunch of meshes, in which case we might set one of them as the root component and then the other ones are attached to it. Imagine a turret attached to a tank. Well, we might have the tank as the root component, the actual body of the tank, and the turret as a sort of sub-mesh of that. So there's quite a lot of flexibility in how we derive, how we create our classes in terms of its composition, but just know that the root component's the thing that should have your kind of the root of your hierarchy essentially. So next, it's setting up a collision profile. It's saying I'm going to be of type pawn, and we'll definitely be coming across collision stuff at some point, so we'll have a look at that later. It's saying set static mesh into the ship mesh component. Actually, thinking about it, it's doing the actual insertion of the static mesh here, shipmesh.object, but what it's doing here is creating the static mesh component and giving a name. So it's actually not created the ship model until this part. So that one's actually kind of loading the model into a uStatic mesh, and then this one's setting that static mesh into the ship mesh component. So yeah. It's caching a sound effect, which is what it says there. Essentially what this F object finder is doing is basically saying, given the game directory and some relative path in there, find the file that we're going to use, cast it to the type of object that we're asking for, and then save it in a static variable. In this case, it's a static variable called fire audio, and then fire audio.object is then fed into fire sound, which is once again another pointer. In this case, it's a usound base pointer defined as a property in the header file. So that one's fairly easy. Should be able to understand what that one's doing. Again, another create default subobject. So if you want to add a component onto a C++ class, you call create default subobject with the name of the class that we want to create and the name of what we want to call it. So each component's got a name. In this case, camera boom. Now, the fact that they've used a text for camera boom here doesn't really matter. It's just what's displayed in the editor. You could call that banana and it would still work. What's important here is that when it's creating default subobject, the thing that is returned is stored in a variable somewhere. And in this case, it's called a camera boom, which is a pointer to a camera here. Yeah, so the uCamera component, sorry, not uCamera component, it's this, where is it? Yeah, the spring arm component. So what it's doing is it's creating, that's weird. Oh, right, yeah, no, I was just looking at that very strangely. So it's creating the uCamera component. Oh, right, it's creating the camera boom, that's what we were looking at. It's creating a spring arm component called camera boom, but it doesn't actually matter, it could call be banana. It's saving it in this camera boom variable, which is down here. So again, the pattern is basically create a U property with a class pointing to the type of class that you want, call it whatever you like, and then in your constructor you run create default subobject with the class name in the brackets there to give it, so it's basically a templated constructor function. Assign it to your variable, and then well, that's it really. So you can do things like attach the component you've just created. So here's the thing, right? Some components need to be attached to things because they actually have some relationship in terms of space. Other components, not so much. They could be data only components which don't really need to attach to the base. So what's happening here is that our first component is our ship mesh, so that's going to be the root. We then attach the camera boom to the root component, which is our ship mesh. We then attach the camera, which we create again with create default subobject, and we set attachment for that to our camera boom. And when you're doing set attachment, you can actually give the thing a socket name. In this case, we're saying attach the camera boom to the end of the spring arm component's socket. So what it means is that you've got a hierarchy where you've got a ship mesh with a camera boom arm that's essentially saying how far away should this thing be from how far away should the camera be from the ship mesh. And then we've got the actual camera itself that's going to look at the ship attached to the end of that camera boom. So there's a bunch of stuff on this spring arm component that you can play with, things like, you know, how fast it travels and whether it's got any lag or all this kind of stuff, and whether it rotates and how far it rotates. One thing I would suggest you play with here is the target arm length. So that's how far away the camera is from the ship. So the camera is an interesting one It's worth looking at different camera functions later on, but for now we'll just go with the defaults. So next part is movement speed. That's just a variable. We're just declaring a value. You could actually do, if we have movement speed here, you could just set the value here as well. You know, you can just do its equivalent essentially, but for now we'll not do that way. Move speed equals 1000. It's just an arbitrary value really. Gun offset is where on the ship we should fire from. It doesn't actually do anything in this class particularly other than like give it an offset. Fire rate is how fast we should fire, so you can play with that in terms of like upping and lowering the fire rate. So let's have a look at the functions. So you remember that there was a bunch of actor derived virtual void overrides. Those are the classes that these are the functions that are declared in a actor as virtual, and then we want to override them, so we use the virtual void override stuff. And so there's two main functions here. One's tick, which we'll cover in a second. The next one is set up player input component. So let's go through that one. And what that one's doing is it's saying it's taking a U input component. So this one's going to be passed from some actor function. It's going to be called by the actor function on our derived class, and it's going to pass in the input component that is default on an actor. Or rather, sorry, default on a, it must be default on an actor. There's a macro here that says check, which basically says check if this value is null or not. So check if there's a value in it, and it'll essentially exit out if it is. So run a check on player input component. It's useful to do those kind of things if you might get a null value passed in. We would expect that not to be the case, but you never know. So having a check in there is kind of useful. So what does player input component do? It allows us to do a thing called binding. So it'll allow us to essentially allow us to map some input to a named thing, a named value. In this case, it's called bind axis, but there's a bunch of different things. There's, you can bind different types of input. Axis is a floating point, like a joystick value essentially, like you would get on the thumbsticks of a D-pad, that kind of deal. Because it's a twin stick shooter, the idea is that you should be able to use two axes, two D-pad axis thumbsticky things. What that means is that it's feeding in this value here, right? Move forward binding means move forward. So when you're mapping in Unreal Engine your inputs, you'll just use the name move forward, and then the code here is actually essentially passing that same string move forward into the bind axis function of the player input component. So all that means is that when you get an input, we mean these words as our input bindings. And what will actually happen is, here's the more interesting thing, right? We'll use the same string to get the actual value. So essentially the player input component saying we're interested in this axis as a value, and then we can actually go get input axis value and pass it the same string. So remember, this is just a const static string that we've defined here. Sorry, an F name, but it's near enough a string. Called move forward, so it's move forward binding. We're going to get the input axis value. That means it's going to get a float value, and it's going to stick it in this float. So basically the tick function, so set player input component is where you would define all of your inputs, essentially your input bindings. Tick is the other actor function, so we know that this tick is an actor function, and this is the thing that's getting run every update. So every update cycle it's going to run this tick function, and it's going to give you how long it's been since the last one was run, so delta seconds. Usually a very small floating point number, but if your game kind of lags a bit, it'll be slightly bigger. So that's the time, how much time has elapsed since the last update. This tick is run. You'll get used to doing ticks functions essentially. So the next part is we're going to get some input values from our thumbsticks essentially. So the forward axis value is essentially forward and back. The right axis value is right and left. So the input mapping is actually done in the editor. So if we go to edit, project settings, and then there'll be an input, yep. And there's just the axis mappings here. So basically the axis mappings will be set up for you when you create the thing from the template. And all it just means is that for this move forward, because remember, if we looked at the code, let's just switch back to the code for a second. Let's switch back to the code for a second. Why are you not switching back to the code? Right, okay. So you remember we gave it a name here, move forward? Well, here's move forward. It just means that like you can set up any input name because you can give it just a text name for any action. So there's action mappings and axis mappings, and we've done an axis for this project. So what we're doing is we're going to go through the tick function and just have a look at what it's doing. First thing is it's storing those two floating point values for essentially one of the thumbsticks. It's then doing a little bit of math to say essentially what direction is the thumbstick pointing in. An F vector is a 3D vector X, Y, and Z value with floats. It's creating an F vector with the forward and right values, so basically whether the stick's forward, back, left or right, and a 0 in the Z. And then it's doing a clamp, so it's basically saying give me a value that's between essentially between 0 and 1. And that's going to be in the move direction. And then we're saying, okay, so given the move direction times the speed times how much time has elapsed, this is how much movement we want to do. And then it's saying if we've got some value in that movement, we then are going to move this ship in the direction of movement. Now, what the code does here, and I don't really like this is why we're going to change it, but it essentially takes the vector that we've given it. So remember, this input vector is just the stick direction essentially, and it's saying our rotation value for the ship is going to be the direction of that movement vector. So essentially the ship is going to move in the direction of the vector that we've given it as input. So the ship will face in whichever direction you've put in your thumbstick. It then does a check to see if it's hit anything, so if the ship can't move or not. So basically it's saying move in the direction of your thumbstick unless you hit something, essentially. And is valid blocking here is just saying, okay, so hit is the result of this move component. So move component is the thing that's going to take care of actually moving us around. I don't think we declared a specific one here, did we? No. So there'll be in the base class, there'll be a movement component as a default, and we're saying, okay, so oh, actually no, it is a function on the, because it's calling root component. See, remember where we created this ship mesh as a root component? So what it's actually saying here is on that ship mesh, which is derived from uScene component, let's get the move component function of that and call it with our movement vector that we want. So basically which direction the thumbstick's in. We're going to give it the rotation value, which is essentially making the ship rotate in the move in the direction of the movement vector. I'm not sure what true does. Let's have a quick look on this. true says whether we sweep, so sweep testing, that's part of the collision stuff for the physics engine, and it's saying if we hit something, stick it in this hit result called hit. So f hit result, if you need to see what's in there, just right click. Why is my right click not working? And then just go to definition. But for now we'll just ignore that. And it's saying if there is a hit, stop moving in that direction. Essentially, it does a little bit of maths to stop you moving in the direction of the hit value. So essentially, if you hit a wall, stop moving in that direction. So next one. I haven't done yet what that was. Fire action. So next one is it's going to get the axis value. So this is stick 1, essentially, the left stick, which is the movement direction. And then the next part is the right stick, which is the direction to fire in. And all that means is, again, it's filling in an F vector, and then it's calling this function fire shot. Now, fire shot is just going to take a direction vector to fire in relative to the ship. What fire shot is going to do is say, if we can fire, then we get the direction and say if it's got some length, size squared is just an easy way of saying, like, has it got some value? And if it has, again, the rotation of the thing that we're going to fire is based on the direction that we've just given it. It's just this rotation is just a function on the F vector class that allows you to get essentially the rotation direction of an F vector, which is kind of a weird thing to do, but hey. And then what it's saying is we're going to spawn a new actor. So we're going to spawn a projectile essentially at the location of this current actor, which is our spaceship, plus the offset for firing rotated by the ship's rotation, if it's pointing in the direction of our in the direction of our movement, essentially. Sorry, in the direction of our firing. So what this means is that essentially it's offsetting the gun offset by the rotation of the direction of our right thumbstick, which is a bit of a weird way of doing it as well. We'll change some of that. So that's going to store that in an F vector, which is our spawn location. And then that's where we're going to spawn our projectile from. So the next part is we want to be able to spawn a projectile. So what we do is we do a thing called get world, which is available on any actor derived class. Get world returns a pointer to the U world, which is the thing that this actor is contained in, which means basically what is the world that the ship's actually contained in. And if it's not null, we're going to call spawn actor on that world. And spawn actor is the thing that actually spawns objects, you know, whatever or type it is. In this case, it's spawning a tiny shooter projectile. It's using the location, which is the rotated offset vector from plus the actor's location stored in here, and fire rotation is just in the same direction as the thing that's pointing the right stick direction, essentially. It's then setting can fire to false, and here's the thing that's actually making it so that it can actually fire again is this timer. So again, on the world there's a get timer manager function which returns the timer manager, and then there's a function on that called set timer. And essentially what that's doing is it's setting up a callback for this shot timer expired function based on how fast it can fire. So fire rate's a variable. Again, if we go back to the header file, fire rate was somewhere up here. Yeah, there we go, fire rate. So that's, again, another variable on the class. It seems complicated, but it's not really. It's just a bunch of functions being called on basic classes. So essentially, it's saying you can't fire again until this timer runs out, and the timer runs out and calls this function shot timer expired, and shot timer expired just says yes, you can fire again now. So this starts off as true, and if it's true it gets set to false after it's fired, and then the timer should time out and call this function, and then this gets set to true again. All it just means is that essentially it's going to try and fire a shot every tick, and it's only going to fire if the can fire is true, and the can fire is true is going to set to false when it's fired and reset to true when it's ended with this timer. So timers are a nice way of doing things at a certain time in the future that don't cost a lot of time because they're not doing a constant check in a tick function. So what's next? It's saying if we've got a fire sound, then play sound at location, which is the location of the ship. So basically, if we've got a sound, play the sound now. And that's it. You don't really need these two can fire false. That's weird. Oh well. Epic's obviously got a bit of redundant code in there. Code. Fair enough. So there you go. That's the shooter porn, tiny shooter porn class. It's a bit rubbish, frankly. I mean, if we go to the actual thing, this is what it is. I mean, it allows you to move. Forget about this flying saucer, you haven't got those yet. It allows you to move, it allows you to shoot projectiles in the direction. I'm using the keyboard here, the WSD to move and the cursor keys to fire in the direction. But you can just plug in a 360 Xbox 360 controller and have that work. It does work as a twin stick thing. But we're not going to do that because we want to change it. So that's that base class, and so we're going to change all of this. This is the thing that we want to probably start off with, right? So we've got this spaceship and it's got controls and stuff, but the code's a bit like poor, isn't it? For instance, the tick function is kind of hard coded how the movement's going to work, right? So this is actually doing our movement for us, and I'm not sure I think that that's a good idea. And the next bit is it's doing our firing for us, and I'm not sure that's a good idea either, particularly. So we're going to refactor this. So I'll end this video here, and then we'll come back to the refactoring in the next one.